I found that a lot of people struggle with algebra unnecessarily. I think people get trapped because of the numbers and the letters make it look too scary, and then they kind of freeze and don't really know what to do. So what I want to do is do an introduction to algebra that didn't really focus too much on the numbers. Instead, what we're going to focus on is how to think about things in general. This will apply not only to math, but other sorts of logical operations, and just how do we think about life and how do we think about the nature of things to make math a lot more understandable. So let's go over some preliminaries just to make sure we're all in the same place. First of all, I'm going to talk a little bit about why we learn math. The point of math is not really solving problems. I mean, you might get into a job where you need to solve a lot of problems, but math is more general than that. So think about biology. If I learn something new in biology, I've learned a new biological fact. I can't really apply that to many other places. I can't take my biology fact and apply it to computer programming. It just doesn't do a lot. But if I learn something new in math class, you actually learn something new about everything, because everything uses math. And math is really just applied logic. So the things that you learn in math class, they'll actually be able to help you out no matter what you do. Okay, and I tell people that the rules of math are not just for math. So what math does is math gives us practice on our reasoning skills. Okay, so there's a core set of reasoning skills. And what happens is that math allows us to practice these reasoning skills. It gives us practice on concrete problems that have definite answers. Okay. Sometimes people say, well, we could practice our reasoning skills on thinking about a trial or thinking about evidence of something, and that's true. But the problem with those situations is that those situations don't always have definite answers, and so it's hard to know if your thinking is correct. So the nice thing about math is it gives us concrete problems with definite answers, and that way we can know whether or not our reasoning was correct. So then we can use that to achieve mastery of the reasoning process. And once we've mastered the reasoning process, and more importantly, we know that we mastered the reasoning process, then that'll allow us to apply that skill to fuzzier situations like trial evidence or other places where we're trying to use our analytical reasoning where the answers aren't as certain. But if we haven't practiced it in places where we know the answers right and wrong, then we're going to have a lot more trouble even being confident in our skills, and justifiably so, because maybe you don't even have those skills yet. So math gives us practice with those skills until we achieve a level of competence that lets us feel good about it. So where should you be on your math journey? Okay, well, when we start math, with little kids, we start with number sense, and that's just understanding, that we have 6 cups, and we set the table. Everybody should have a cup, and if we have 5 people, we have 5 cups. If we have 6 people, we have 6 cups. Just getting a sense of numbers around us. Then we learn arithmetic, which I consider the boot camp of math. And being able to do arithmetic well is actually really important for algebra. In fact, one of the things that I've found is that a lot of people struggle with algebra only because they didn't learn their arithmetic well enough. If you learn arithmetic inside and out, algebra becomes much easier. If you can multiply in your head and divide in your head, then doing algebra will become pretty simple for you. The other thing is understanding the order of operations, because those are very important, as we'll see going forward. Knowing the order of operations for math that's written down really helps you understand what you read when you read a math equation. And I'm actually going to assume that you understand extremely simple algebra concepts. So first of all, you should understand math notation: plus, minus, multiply, divide, square root. those sorts of things. You should know what they mean. Understand basic laws like the associative law, the distributive law, and the commutative law. And then you should be able to solve for very simple unknowns. Like if I say 2 times x equals 8, well, what am I saying? I'm saying what times 2 times what is 8. And so that what, if you really know your multiplication tables, you should be able to know pretty instantly that 2 times 4 is 8. Okay. And as I said, we found that the best predictor for your ability to grasp algebra is your ability to do arithmetic in your head. And I don't mean hard stuff. I just mean like basics, your basic math facts. So the core of algebra is equations. So what is an equation? Okay. Well, equation simply is a relationship, and it says that 2 different mathematical formulas actually represent the same value. Okay. So keep in mind, if 2 things are equal, that means that they are the same. And this sounds obvious, but you would be surprised how many times you can put it to use, and people don't think to, because they forget that anytime we have 2 things that are equal, they are actually the same thing. So here's a simple example: 2 plus x equals 7. Okay, well, we have this equal sign between them, and this guy says that the 2 sides are equal, which again means they both represent the same value. Okay, so that means that this 2 plus x is the same value as this 7. Okay, so these 2 sides are equal to each other. They're the same final value. They're just written in different ways. And in fact, on the left side, there's a variable in there, meaning that we don't yet know part of it. Okay, so the goal, when you get an equation like this, the goal is to find a value for x that makes the relationship true. So 2 plus what is the same value as 7. Okay, so hopefully you already knew that, but just kind of a review. I find it's important to keep the basics in mind, because sometimes the basics are really what save you. So just always remember that the equal sign means that these 2 things are really the same value. Okay. Now we're going to go over rules that you should absolutely keep to heart. These are essential to all of your math that you'll ever do. Okay. So rule number 1, you can do anything to an equation you want as long as you do it to both sides. Okay, this is kind of the fundamental rule of algebra. You should never ever forget this. From early algebra through calculus, I have my classes repeat this almost every day. You can do anything to an equation you want as long as you do it to both sides. And think about why. If those two formulas represent the same value, then it doesn't matter what you do to either of them. As long as you do the same thing to both of them, since they were the same, if you perform the same operation, it will give you the same result. Okay, so the one caveat is that the thing that you do has to be precisely the same thing. Okay, so let's imagine a painting. Okay, now let's imagine an identical painting. Okay, so since these paintings are the same, we're going to say that they are equal. Okay, so now so the rule says that I can do anything I want as long as I do it to both sides. So if I modify one painting but not the other, then they're no longer equal. Okay, and also I have to do the same thing to both sides to get them to be equal. If I do different things to each side, they're still not equal. However, if I do perform the same operation to both sides, then they'll be equal. Okay, so here I have the painting, and I did the same operation to both sides, and so therefore both sides still remain equal. Okay, so if I duplicate one side, but I don't duplicate the other side, the sides are unequal again. But if I duplicate both sides, then the 2 sides are equal. Okay, so I can do anything I want as long as I do the same thing to both sides. Okay. Now, there is actually one operation that I can do to only one side and still have both sides be equal. And this is very important. It will sound unimportant, but I promise you it is very important. And that is, I can do nothing. That is, there is an operation called doing nothing that I can do to only one side. So if I do a do nothing operation to the left side, then it will still remain the same as the right side. If I do a do nothing operation to the right side, it's still it's still equal to the left side. So that brings us to rule number 2, and that is the one operation that you can do to only one side is nothing, which in math we call this the identity operation. Okay, so generally you can do anything you want as long as you do it to both sides. But for identity operations, which means you're doing nothing, then you can do those to only one side. And the reason for this is that when you do nothing, you're only changing the way that one side is written. You're not actually changing the value. So in math, we have several things that do nothing. You can multiply by 1. You can add 0. You can simplify. Or you can replace something with its equivalent. Okay, all those things are do-nothing operations in math. And so, as I said, they don't change the value. They just change the way that you write it. And these actually, as I said, it may sound silly that you're doing nothing, but these are actually very important in developing your math skills. We'll see in later talks how to make use of these to do really powerful work in mathematics. Okay, so that's rule number 2. Rule number 3 is always know the undo operation for each math operation. Okay, so most math operations have an undo version, and this, in math terms, this is called an inverse operation. So for example, if you multiply, then you can divide to undo. If you divide, you can multiply to undo. If you add, you can subtract to undo. And if you subtract, you can add to undo. If you square something, you can square root to undo. Now, one caveat with square root is that if you square root, square root has more than one value, so it's not an exact inverse. So that one's a little trickier. But then square root, you can square to undo. Okay, so again, let's imagine a painting. Okay, now, so we're going to have an operation. Our operation is rotate right. Okay, so now what would be the undo operation for rotate right? What is it? That's right, rotate left. Okay, so now pay particular attention to the painting right now, because the operation we're going to do is, notice how the door is kind of facing to the left a little bit in that painting? Well, if we reverse the painting horizontally, now the door is facing to the right. Okay, so that's an operation. So what is the undo operation for reversing horizontally? Well, actually, in this case, it's its own undo operation. If you reverse it horizontally again, you will undo the original reversal. Okay. The next one we're going to do is erase the painting. Okay, so here we've erased the painting. So now what do you think the undo operation is to erase? Well, actually, if you erase the painting, there's no undo operation available because there's no information that we have to reconstruct the original painting. When we erase, if we rotated it right, we still have all of the details of the painting that we can then rotate back left. When we reversed it horizontally, all the details of the painting are still there that we can reverse it back. But when we erase it, then we've actually lost information about the painting. So we can't undo that operation. So there are some math operations that lose information. And when that happens, it makes it difficult, or it makes it impossible to exactly reverse it. Although sometimes there is, you can do a partial reversal. So erasing the painting is a lot like multiplying by 0. Okay, it gets rid of the painting, and you can't reverse the process. This is why you can't divide by 0, because multiplying by 0 erases all the information. So if you try to divide by 0, you're trying to get the information back, but it just isn't there. So there's no ability to figure out what the information would have been that was lost by multiplying by 0. All right. So now we're going to look at another operation, and that is do nothing. Okay. So if we do nothing to the painting, well, first of all, so the reverse operation is still doing nothing, but actually we didn't need a reverse operation to begin with. If your operation literally does nothing, then there's nothing to reverse. And as we talked about earlier, these are known as the identity operations. And to go to review, some examples of doing nothing are adding 0, multiplying by 1, applying simplifications, and applying the various laws like the associative law, the distributive law, the commutative law. Those things are all doing nothing because you're not changing the value, but you might be doing something important by changing the way it is written that helps you solve later on. So the next rule is that solving an equation means getting the unknown by itself on one side. So this also might seem obvious, but it's something to always keep in mind. So remember, if any two things are equal, that means they're the same. So if your equation looks like x equals blah, then whatever is in that blank is the value of x, because they're the same. That's what the equal sign means. So when someone says, hey, solve for x, what you do is you actually try to manipulate the equation by doing the same thing to both sides, or doing a nothing operation. You keep on doing these things until x is all by itself. And so basically a lot of equation solving is looking at an equation, and then you pick undo operations and do nothing operations. So you do an undo operation to both sides, you do a do nothing operation to one side, you keep on going over and over and over again until you eventually wind up with x all by itself. Okay, so again, we're going to go back to our images to see this in action. So in this case, x will represent an unknown drawing. Okay, so we're going to use the rules that we have discussed so far to find out what this unknown drawing is. Now keep in mind that the order of operations is important. So an undo operation should start at the last operation, otherwise you aren't undoing things. So imagine when you're typing on your word processor, when you hit the undo button, that undoes the last thing that you did. It doesn't undo something that's in the middle. It always undoes the last thing that you did. And so likewise with math, we always undo the last operation that was done, which if you're using parentheses and all that is usually the outermost operation available. So here's our problem. On the left side, we have a drawing. And on the right side, we have the list of steps that we did to get this drawing. Okay, so X is not the drawing. Okay, X, so if you notice we've got 4 steps. The first step was to draw X. The second step was to flip the image horizontally. The next step was to rotate the image to the right a quarter turn. And the final step was to change black to white and white to black. Okay, so those are 4 steps that lead to the image that you have on the left. Okay, so as I said, the image on the left is not X. That's the result of doing all of the operations on the right side. So how do we figure out what X was? Well, what we can do is we can undo all the operations on both sides until we wind up with X all by itself. So what's the operation to undo? Well, we always undo the last operation. So the last operation in this case was changing black to white and white to black. So the inverse of that would be just to do it again. Change black to white and white to black. So we're going to undo it. boom, there is, now we've undone it, and we undid it on both sides. We did the same thing to both sides. So undoing the last operation on the right just basically gets rid of it, and undoing the operation on the left changes what it looks like. Okay, so now what's the next thing that we have to undo? Well, the next thing we have to undo is this rotate image to the right a quarter turn. Well, if the operation was to rotate it to the right, what's the undo operation? Well, the undo operation is to turn it to the left. So that's what we're going to do in the next step, is we're going to rotate the image to the left a quarter turn. Okay, so we undid that operation so it no longer exists on the right. And so notice we did the same thing to both sides. In the left side, we turned it to the left, and on the right side, we turned it to the left, and so that undid the operation, and it got rid of it. It canceled it out. So now, what's the next operation to undo? Well, the next operation is to flip the image horizontally. Well, what's the undo operation for that? Well, it's to flip it horizontally again. So this is our next undo, and so we're going to undo it now. Boom. So we undid the operation on both sides, and now we have our answer. Draw X means to draw the image on the left. So anyway, so that's kind of the way that you use undo operations to arrive at your X value. You just kind of unwrap the equation one step at a time until you are finally to the X value. So now we're going to do an actual problem and show you how to apply these rules using math. Okay, so the problem is going to be 4 times the square root of x minus 5 equals 12. So remember, the goal is to get x all by itself. Then whatever is on the other side will be equal to x. Okay, so the 2 questions we need to ask ourselves is, what is the last operation on the side containing the x? Okay, well, the last operation, and then second question we need to ask is, what is the undo operation of that? Okay, well, in math, the last operation is always your outermost operation. So it's going to be the multiplication between the 4 and the square root of x minus 5. Okay, so what's the undo operation of multiplication? Well, it's division. So we're going to divide both sides because we're trying to isolate x by itself. So what we want to do is we want to divide both sides by 4, which will get rid of the 4 on the left. So here's what it's going to look like. We're going to divide both sides by 4. Okay, so notice we divided by 4 on the left, we divide by 4 on the right. Now, canceling terms is just a simplification, so that's a do-nothing operation. So we can do that separately to both sides. So on the left, 4 divided by 4 cancels the 4's out, and on the right, 12 divided by 4 gives us 3. Okay, and so after doing that operation, we have the square root of x minus 5 equals 3. So now we have the square root of x minus 5 equals 3. Now, what's the outermost operation? And what's the undo operation for that? The outermost operation here is square root, and the undo operation for that is squaring. So what we're going to do is we're going to square both sides. So so notice here we've squared both sides, and so on the right side, 3 squared simplifies to 9. Remember, simplifications are do-nothing operations. So 3 squared simplifies to 9, and on the left-hand side, the square of the square root is just the value itself. So since x minus 5 is what was square rooted and then squared, then we get x minus 5 out. All right, so now we have x minus 5. So again, we're going to ask ourselves, what's the outermost operation and what is the undo operation of that? Okay, well, x minus 5, subtraction, is the outermost operation, and the undo operation of subtraction is addition. So we're going to do add 5 to both sides. So if we add 5 to both sides, then we're going to have x minus 5 plus 5 equals 9 plus 5. So applying, doing the simplifications is a do-nothing operation, so we can do that separately to both sides. So on the right, 9 plus 5 becomes 14, and on the left, x minus 5 plus 5 is just x. So now we get to x equals 14. With x equals 14, since the left side is since the left side has x by itself, and there's an equal sign, that means that the value of x is 14, and that's what we're trying to solve. Now the fifth rule is that anything that is equal can be replaced by what it is equal to. Okay, and you can call this the replacement rule or the substitution rule. And it basically says, so this just goes back to what the equal sign means. The equal sign means that the two values are the same. So if the two values are the same, then we can always replace one with the other. Okay, so let's say that I know that y equals 5 and x equals y plus 2. Well, I can use the replacement rule to solve this, because I can simply replace, in the second equation, I can replace the y with 5, because in the first equation it said y and 5 are equal. So that means they're the same, and that means I can always use one where I had the other. So I can simply substitute in 5 for y. X equals 5 plus 2, therefore x equals 7. And I can use the same rule for complicated things as well. So let's say I have y squared plus 1 equals 7. Okay, so then I have x times y squared plus 1 equals 14. Well, on the first equation, I already said that y squared plus 1 is equal to 7. Since y squared plus 1 is equal to 7, I can replace any instance of y squared plus 1 with the value of 7. So in the second equation, I have a y squared plus 1. So I can change that, I can exchange that for 7, because that's what the equal sign tells me to do. So that means x times 7 is 14. If I divide both sides by 7, I'll get x equals 2. Okay. Now one thing to note is that when doing this, parentheses must be used on replacement. That is, when you substitute the value in, it should be wrapped in parentheses. And the reason for this is that it keeps the order of operations correct. So in this example, we're going to have y equals 4 plus 2, and x equals 3 times y. Okay, well, if we substitute, so the correct way to substitute it in is with the value of y, with the thing that you're substituting for, in parentheses. So if we substitute 4 plus 2 for y, we're going to wrap that 4 plus 2 in parentheses. Okay, and that's going to allow us to keep the order of operations correct. And so that will give us x equals 3 times 4 plus 2. Well, 4 plus 2 is 6, because we always do our parenthesize operations first. And 6 times 3 is 18. What would be incorrect is if we substituted in 4 plus 2 without the parentheses, because then our order of operations would be wrong, and we would get the wrong value. Okay. So here you see that when we wrap the substitution in parentheses, the value will come over as a holistic unit all by itself, and so keeps the order of operations correct. But when you fail to use the parentheses, it means that it's not coming through as a single unit. So you can think about, if you've ever seen Star Trek, where they have beam me up, Scotty, and they use the transporter beam. Well, if you don't use parentheses to bring over substitutions, it's like a bad transporter. If you've ever seen one of those episodes where they just only transport part of a person and they lose them in transmission. Well, that's what happens if you try to substitute without parentheses. All right. So the replacement rule can be used to remove variables. So if you have multiple equations and multiple variables, we can use the replacement rule to simplify things. So let's say that I had the equation y minus 1 equals x plus 24, and I also had the equation x plus 1 equals 4 times y. So what we can do is we can take one of the equations and solve for one of the variables. So on the left side equation, let's solve for y. We can do that by adding 1 to both sides. So that will leave us with the equation y equals x plus 25. Now notice, we now have an equivalency between y and x plus 25. So that means anywhere we have y, we can replace it with x plus 25. So we can now go into our second equation and replace all of its occurrences of y with x plus 25. So this will give us a new equation. X plus 1 equals 4 times, it was y, now it's x plus 25. And now I can solve for x. I can use the distributive rule to say x plus 1 equals 4x plus 100. And then I can subtract x from both sides and subtract 100 from both sides, and that'll give us negative 99 equals 3x. Divide both sides by 3, and I'll get x equals negative 33. And now that we know x, we can use it to find y using either one of the equations. So since x is equal to negative 33, we can simply substitute negative 33 in for x. So we have y equals x plus 25. Well, y equals negative 33 plus 25, which is negative 8. So rule number 6, you need at least as many equations as you have unknowns to solve for the unknowns. With one equation, I can discover the value of one unknown. So x plus 5 equals 20, I can figure out that x equals 15. But if I have two unknowns, I need at least 2 equations to figure out the values of those unknowns. And then if I have 3 unknowns, I need at least 3 different equations to find the values of these unknowns. Okay? Now sometimes that isn't enough. Sometimes a system of equations will have more than one solution, especially where squares are involved, because there can be more than one square root. Sometimes a system of equations will have an infinite number of solutions because one of the equations doesn't actually add information about the system. What we're relying on with having 3 equations for 3 unknowns is that each of those equations adds a new idea to the mix that allows us to solve. But sometimes we'll have 2 equations or we'll have 3 equations, but 2 of them are actually the same equation written different ways. So one of them doesn't actually add in information. So having genuinely new facts is what helps you solve a problem, and does it by reducing the number of possibilities that are available. So if 2 equations mean the same thing, one of them did not add any new facts. So here's a summary of our rules. Rule number 1, you can do anything you want as long as you do it to both sides. Rule number 2, you can always do nothing, the identity operation, even if it is only to one side. Rule number 3, always know the undo, the inverse operations. Rule number 4, solving an equation means getting your variable by itself. Rule number 5, the replacement rule. You can always replace something by something it is equal to. And this is really an extension of rule number 2, but we have it as its own rule because it is so important, so often used. And finally, for rule number 6, for however many unknowns you have, you need at least that many equations to find out what the unknowns are. Anyway, I hope this was helpful to you and will help you get ahead in mathematics and algebra.